Welcome back, focus learners. Okay, let's dive into this. Today, we're unpacking an explainer that completely flips the script on what is traditionally one of the most tedious parts of Class 9 math. We've all been there, right? Staring down a complex cubic polynomial on a test, just dreading the absolute mountain of algebra that lies ahead of us. But what if I told you there is a mind-blowing shortcut hidden right in the numbers themselves? Seriously, why spend 26 minutes factoring? If you search for traditional tutorials on the factor theorem, you're going to see runtimes clocking in at 26 minutes, sometimes even 38 minutes, just to teach you how to solve a single cubic polynomial. It's a painful process. You have to use trial and error to find the first root, set up this massive long polynomial division bracket, carefully track all your negative and positive signs so you don't make a careless error, and then finally split the middle term of the remaining quadratic equation. It is exhausting just thinking about it. So, here we have a stark comparison of your options. On one side, the traditional factor theorem. We're talking over 26 minutes of dreaded, time-consuming long division and algebraic heavy lifting. On the other side, the heuristic trick sourced from our materials today, which takes a mere 2 seconds once you know what to look for. It's almost suspiciously fast, I know, but it relies on recognizing a beautiful underlying mathematical pattern. Section 1, the 2-second math trick. Okay. To solve our polynomial instantly, we are going to completely bypass writing out the long, intimidating algebraic equation. Instead, we only extract two highly specific pieces of information. We just look at the target coefficients, the x-squared coefficient, which happens to be -6, and the constant term at the very end of the polynomial, which is +10. That's it. We ignore the x-cubed term, we ignore the regular x term, we just need the -6 and the +10.
And boom, here is the final factored answer. X minus 5 times x minus 2 times x plus 1. Wow, I know. It feels like we just skipped 3 entire pages of a math textbook, right? That is the promised 2-second trick at work. Now you're probably sitting there wondering how on earth we jumped straight from two isolated coefficients directly into the final factored form without a single line of long division.
Section 2. Breaking down the logic. Now, what's really interesting about this slide is how it pulls back the curtain and deconstructs the math for us. All right, here is the exact methodical 3-step logic required to find those magic numbers. Step 1, find the factors of the constant, which in our case is +10. Step 2, pick exactly 3 of those factors that add up to the x-squared coefficient, which is -6. And step 3, ensure those same 3 factors multiply to give you the constant back, +10. That's the entire system. No algebra, just basic arithmetic. Let's actually walk through it together.
Let's focus strictly on step 1. We isolate the constant term, which is +10. Identifying its factors is our starting point here. We just need to know what integers can cleanly divide into 10 without leaving any sort of remainder.
Let's visually sift through these options. The factors of 10 are +1, -1, +2, -2, +5, and -5. See? This list right here is our limited pool of options. We don't have to guess random numbers out of thin air. The answer absolutely has to be built from a combination of these exact 6 numbers. Now we apply the next constraint with step 2. We need to select exactly 3 numbers from that previous list of 6. But not just any 3. When added together, their sum must equal -6. This drastically narrows down our search and gives us a very clear target to aim for. So the crucial point is right here in step 3. You must verify that the product is the constant. Those exact same 3 numbers we just picked to add up to -6 must also multiply together to give us +10. It's kind of like a dual condition lock, and only one specific combination of keys will turn the cylinder. And here is that winning combination isolated for you. -5, -2, and +1. Out of our initial pool of 6 factors, these are the absolute only 3 numbers that perfectly satisfy both the sum rule and the product rule. Let's actually prove the math really quick. Let's prove the math side by side. I just love how clearly this validates the concept. For our sum check, -5 plus -2 equals -7. Add the 1 and we get exactly -6. That perfectly matches our x-squared coefficient. Now for the product check. -5 times -2 gives us a +10. Multiply that by 1 and it stays +10. That perfectly matches our constant. You see, the numbers align flawlessly. And this brilliantly illustrates how those three winning numbers plug directly into your final answer. You simply drop them right next to the x's inside the parentheses, x minus 5, x minus 2, x plus 1. You have completely factored a cubic polynomial, a notoriously difficult task, using literally nothing but simple addition and multiplication. No way, right?
Section 3. Work smarter, not harder.
Let's move to Synthate and see how this builds your overall mathematical toolkit. First and foremost, it entirely bypasses the friction of long division. Secondly, even if your teacher requires you to show your work using the traditional factor theorem, this acts as an instant, foolproof verification tool so you literally know the final answer before you even write your first step. And finally, it saves massive amounts of time on competitive exams, where, let's face it, every single second counts.
So I leave you with this provocative thought. Will you use the long way or the 2-second shortcut on your next test? Math isn't just about grinding through the hardest, longest path. It's about recognizing the brilliant patterns that let you work efficiently. Challenge yourself to apply the insights from this explainer the next time you face a cubic polynomial and watch your math anxiety disappear in exactly 2 seconds. Keep learning, keep questioning, and I'll see you in the next explainer.